Hey, welcome to the Explainer. Today, we're going to break down two concepts from physics that are, well, absolutely everywhere you look, from the tallest skyscrapers right down to the incredible spins you see at the Olympics.
So let's kick things off with a question. You've seen this a million times, right? An ice skater is spinning, and then they pull their arms in, and whoosh, they suddenly speed up like crazy. It looks like magic, but it's actually just pure, elegant physics. So how does it work?
Okay, so before we can even get to those incredible rotational speeds, we've got to go back to square one. We have to figure out how objects balance in the first place. So let's dive into that. All right, so this right here, this is the core idea. It's called the center of gravity. Think of it as an object's perfect sweet spot. It's this one single, almost magical point where the object's entire weight seems to be concentrated. I mean, if you could literally balance the whole object on the tip of your finger, that's the point you'd be touching. And here's the cool part. For a lot of simple, everyday things, you probably already have a gut feeling for where this point is. Your intuition is probably spot on. Let's look at a few easy examples to really get a handle on this. Okay, so check this out. You see the pattern here, right? For things that are, perfectly uniform and symmetrical, like a plain old rod or a rectangle, the balance point is exactly where you'd think it is, smack dab in the geometric middle. Super simple, super predictable.
That's easy enough for a perfect rectangle, but let's be real. The world isn't made of perfect rectangles. So how do engineers figure out the balance point for a really weird, irregular shape, like some kind of custom machine part or a complex piece of a building?
Well, it turns out there's a really elegant method for this. It's not just guesswork. What you do is you basically chop up that complicated shape into a bunch of simple ones you already know, your basic rectangles and triangles. You find the center for each of those little pieces. And then, and this is the clever part, you essentially calculate a weighted average to find the one true center of gravity for the whole thing. So the big takeaway here is center of gravity is all about balance. It's the stability point. But here's the thing, that's only half the story for our spinning skater. To really understand the spin, we need the other piece of the puzzle. And this slide, right here, perfectly sets up that other half. So you have the center of gravity, which is for an object just sitting there being stable. Then you have this other thing, moment of inertia, which is all about how much an object fights you when you try to spin it. You can think of it as its rotational laziness. So let's dig into that a little more. And listen, this is absolutely crucial. Moment of inertia isn't just about how much an object weighs. No, it's all about how that weight is spread out from the point it's spinning around. And I am not kidding when I say this is everything. When we're talking about spinning, the distribution of that mass isn't just a small detail, it is the whole shebang. So why is it so important? Well, here's the kicker. As you move mass further away from the center of rotation, the moment of inertia doesn't just go up a little. It goes up dramatically. That's because in the physics behind it, that distance gets squared. So if you double the distance, you're not doubling the resistance to spin, you're quadrupling it. It has this huge outsized effect. Okay, so now we have both our key concepts. We've got the center of gravity for balance, and we've got the moment of inertia for spinning. Let's put them together and finally crack the code on our ice skater. Okay, so picture this. The skater starts the spin with her arms stretched way out. All that mass in her arms is far from her center, right? That means she has a really high moment of inertia. It's hard to spin fast like that. But then she pulls her arms in tight. Suddenly, all that mass is super close to her axis of rotation. And what does that do? It slashes her moment of inertia. Now, physics has this unbreakable rule called the conservation of angular momentum. And it basically says that if your moment of inertia goes way down, something else has to go way up to keep things balanced. And that something else, it's her speed. That's it. That's the magic. So there you have it. It's not a trick. It's just beautiful, elegant physics playing out right in front of our eyes. And believe me, these ideas aren't just for a skating rink. They are literally the foundation for so much of our world. So why should you care about any of this? Well, think about it. Understanding center of gravity is the only reason engineers can build stable skyscrapers and bridges that don't just, fall down. And moment of inertia? That's critical for anything that rotates. We're talking car engines, planets, you name it. And of course, for athletes, divers, gymnasts, dancers, mastering their own moment of inertia is how they pull off those mind-blowing flips and spins. So now that you're in on the secret, start looking around. Where else do you see this stuff in action?
From the way a satellite holds its position in orbit to the simple design of a kid's spinning top, you'll realize it's everywhere. The physics of balance and rotation aren't hidden away in a textbook. They are shaping our world right in front of us every single day.